Hi everyone, welcome to day 16. Homework is day 16 worksheet, which is in your packet. Do not open your notes packets yet. Here is some of the homework ones for you to check, and we will scroll down momentarily to check the other couple. So I'm going to scroll down so you can see 13 and 14, and we're going to pause the video for 1 minute for you to check all of your answers. All right, now for the textbook problem. So an accumulation function starting at 0. So you're just doing the area added on each time, the positive and negative areas, and you see the chart there. Because f was linear, there was no increase or decrease, so that should lead to no concavity when we graph it. So we should have all linear sections. G has a minimum when f switched from negative to positive, so when x equals 6. G had a maximum when f switched from positive to negative, so x equals 2. The greatest increase at the rate would be when f had its greatest value from 6 to 10. And then the zeros of G, we can just look at in our picture or from our table. All right, so since I don't know which ones you will want to go over, I'm just going to pause on the worked out solutions for like 45 seconds, and we'll just let the video keep running. So if you had any 1 through 8 that you had difficulty with, you can take a look at those ones. Now here's 9 through 14. Again, we're just going to let the video run for about 45 seconds, so you can check any of these that you had difficulty with. All right, so again, do not open your notes packets yet. Please keep them shut. So this idea of substitution, here in this case we're doing U substitution. You've actually seen an idea with it before in Algebra 2 and Pre-Calc when you solved trig equations. So often how you work with these is you do a let statement, like maybe you let y equal tan theta. So now this becomes y squared minus y equals 6, or in other words, y squared minus y minus 6 equals 0. That factors into y minus 3 and y plus 2. So in other words, y equals 3 and y equals negative 2. Well, then we brought back in at the end, it's not actually y, it's tan theta. So it'd be tan theta equals 3 and tan theta equals negative 2. And then from there, you would do your inverse tan and your ASTC to find your answers for this. But this idea of substitution to create a simpler setup and then working with that simpler setup and then subbing back in the end is something that you've seen before. So again, still not opening our notes packets. So in these two integrals here, they look completely different. In the left-hand one, we'd want to recognize we have a function inside of a function. So u would equal x squared plus 1. So du would equal 2x dx. Well, notice that's a perfect match with our leftover, so we'd end up with integral of u to the 4th du. Over here, we've got a function inside of a function, so we'd let u equal sine x minus 5, so du would be cos x dx. Notice again we've got a perfect match, so the cos x dx will be your du, and we'll have u to the 4th. So what I want to point out here is notice in terms of u substitution, they have the exact same, it has the exact same look once you do the u substitution. But the meaning of the integrals is different, even though they're both u to the fourth du, because we've defined different u values. So although we will end up doing the same antiderivative here in the long run, these will end up different because we defined u differently. Okay, so because I am not here today, we're not going to be able to work in groups on the whiteboard. So we are going to work in our notebooks. And what I'll do is we'll put an integral up on the board and we'll give you maybe 3 minutes to go through and do that. And while you are doing that, you are welcome to work with the people nearby you. And then at the end of 3 minutes, we'll hit play and we'll go through the solution for that. So again, we'll pause the video for 3 minutes right now. See if you can do this integral in your notebooks. All right, so for this one, our inside function is u to the fifth plus, or x to the fifth plus 7. Let that equal u. Your du ends up as a perfect match for the leftover. So the 5x to the fourth dx gets replaced with du. We have u to the third. Do your antiderivative, sum back in. Here's your second one to do. That's a square root symbol, by the way. The top of it kind of didn't line up perfectly. And let me just rewrite this so it's perfectly clear. So this is 6x squared plus 2x under the square root, and the 6x plus 1 dx is being multiplied afterwards outside of the square root. So we're going to again pause for 3 minutes, see if you can do this integral. All right, in this case, our function inside of another function is the 6x squared plus 2x. Let that equal u. Your du is 12x plus 2. Make sure that's all in parentheses and times the dx. From there, we need to do a correction of multiplying by a half. So now the 6x plus 1 dx is going to replace with 1/2 in du. Put the 1/2 out front, put the du at the end, and then we've got u to the 1/2 from our square root. New exponent is 3/2. Multiply it out front by 2/3, so we get 1/3 as a coefficient, and replace u with what it was equal to. Here's your next one. Again, doing these in your notebook. We'll pause for 3 minutes for you to try. So here we have two options for u. We could let u equal 4x, or we could let u equal sine 4x. Both are functions inside of a function. If you let u equals 4x, you still have a sine to the 6th and then a cos, which is not something we can handle. But if you let u equal sine 4x, we'll get cos 4x times 4. That's close to matching our leftover. We just got to correct by multiplying by a fourth. Now the cos 4x dx will get replaced with the 1/4 du. Oh, I got a little error there. That should be du right here. And then we got u to the 6th for the sine to the 6th. Exponent goes up 1 to 7. Divide out front by 7. You get 1/28 sine to the 7, 4x plus c. Here's your next one. Again, we'll give you 3 minutes to try it. For this next one, we've got secant to the 6x tan x. So let u equals secant x. So for du, we need a secant x tan x. So notice I rewrote it. I bumped one of the secant x's over to go with the tan x dx. Now that all becomes our du, and we're just left with a u to the 5th for the other secants. Exponent goes up 1, divide out front by that exponent. So 1/6 secant to the 6x, secant x to the 6 plus c. All right, we'll do one more, and we'll pause for 3 minutes for you to try this one. All right, for this one, let your u equal the inside of the cos function, the 2x squared minus 4x. Antiderivative is 4x minus 4 dx. So we need to correct by multiplying by 2. So the 2 in the du will replace the 8x minus 8 dx, and then you got the cos u for the other part. Antiderivative of cos is sine. Sub back in for u. All right, we are now going to open our notes packets, and we're going to flip in the 2-16 to where it has special case. And we're going to look at 2 special cases. So we'll give you a couple seconds to flip to that. All right, so first recognition is we cannot do this antiderivative as is. It's not one of our basic rules. We've got a function inside of another function, so we're going to let u equal that. So we'll let u equal x plus 5. So therefore, our du would just be equal to dx. So right now, this is taken care of. This is going to be a u to the 1/2. The dx is taken care of. That's going to be du. But we've got a leftover x. So you can't achieve that by multiplying by a constant in our du. Okay, we should only be multiplying by a constant ever in our du. So if you have a case where you've got an extra x, what you can do is go back up to where you defined u and use that to replace the remaining stuff in terms of u. Well, our remaining thing is x. So let's take this u equals x plus 5 and let's get x by itself. If we subtract the 5 over, that means u minus 5 is the same as x. So what we'll do now is we'll replace the x with u minus 5. So it took a second substitution when we did our u substitution, but it's still in terms of u. Your integral cannot be an integral of a mix of variables. It needs to be a single variable. From here, we're just going to distribute. So we're going to get u to the 3/2 minus 5u to the 1/2 du. And now we'll do our antiderivative. So u's new exponent will be 5/2. Out front will become 2/5. And the next one, the new exponent is 3/2. We'll multiply out front by 2/3, so we'll get negative 10/3 plus c. And then replace your u with what it's equal to. So we got 2/5 x plus 5 to the 5/2 minus 10/3 x plus 5 to the 3/2 plus c. So I'd say this occurs only in about 5% of cases with u substitution. So it's when you've got something left over that involves an x, go back to your u and see if you can sub in for that thing in terms of u. So for this next one, we want to recognize can't handle it as it is. So we're going to do a function inside of a function, so we'll let u equal the 2x plus 4. So our du will be 2 dx. Well, we have this taken care of right now. That part's going to be u to the 1/3. We can handle that. We've got a 3 and a dx that's left over. So let's multiply both sides by 3/2, and that'll give us a 3 dx. So now the 3 and the dx are going to get replaced with 3/2 and du. But we still got to replace that x. So let's go back to the original u equals up here, and we're going to work to get x by itself. So I'm going to start by subtracting the 4 over. So u minus 4 equals 2x. Then I'm going to divide everything by 2. So we get 1/2 u minus 2 equals x. So that's what we are going to replace our x with. And now we're just going to neaten up. We got two things we're going to be distributing. We're going to distribute the 3/2 and the u to the 1/3. So 3/2 times 1/2 is 3/4. U to the 1/3 times u will give us u to the 4/3. We'll distribute them both to the -2. 3/2 times -2 is -3. And then distribute the u to the 1/3. We'll put it all in parentheses with a du at the end. Now we're just ready to take our antiderivative. So exponent's going to go up 1, so we'll have 7/3 as the new exponent. We'll multiply out front by the reciprocal of that, 3/7, so we'll get 9/28. We'll have u to the 4/3 out in our exponent. Multiply out front by 3/4, so we get 9/4 as our new exponent plus c. And we'll finish off just by replacing. So we'll have 9/28. Our original u was 2x plus 4. Minus 9/4 at 2x plus 4 raised to the 4/3, and then a plus c. So again, that's when you have to do an extra substitution. They tend to be tricky, and I'd say it happens in about 5% of you substitution cases. All right, that is it for this video. Any time left in the period, you can go ahead and either work on your homework or work on the problem set. Have a great rest of your day.